By this point in your journey, you have already set up a working environment. You know how to use a code editor, open a terminal, interact with a browser's developer tools, and read error messages. These are the technical foundations. But becoming a developer is not only about learning tools and syntax, it is also about adopting a way of thinking, a mindset, that will determine how effective and autonomous you become over time. This chapter focuses on two core pillars of that mindset: the ability to break down a problem into smaller, manageable pieces, and the habit of staying curious and exploring actively. Why mindset matters as much as technical skill. Many beginners focus almost exclusively on learning syntax, how to write HTML tags, how to structure a CSS rule, how to call a JavaScript function. This is necessary, but it is not sufficient. The real challenge in development is rarely about remembering the exact name of a property or a method. It is about figuring out what to do when something does not work as expected, when a feature needs to be built from scratch, or when a bug appears and you have no idea where it comes from. Experienced developers are not people who know everything by heart. They are people who know how to approach problems systematically, how to ask the right questions, and how to find the information they need efficiently. That is the developer mindset. It can be learned and trained, just like any other skill. Problem breakdown, the core technique. The single most important habit you can develop as a beginner is learning to break a large, vague problem into smaller, precise, and actionable subproblems. This technique is sometimes called decomposition, and it is used at every level of software development, from designing a full application architecture down to fixing a single bug. Here is a concrete example. Imagine you were asked to build a contact form on a web page. If you stare at the blank page thinking I need to build a contact form, you will quickly feel overwhelmed. But if you break it down, the problem becomes manageable. First, what does a contact form contain? It needs input fields, a name field, an email field, a message field, and a submit button. Second, how do you create these elements in HTML? Each input needs a label and an appropriate type attribute. Third, how should the form look visually? This involves CSS styling, spacing, fonts, borders, colors. Fourth, what happens when the user clicks the submit button? This involves JavaScript behavior, collecting the data, validating it, and potentially sending it somewhere. By splitting the problem this way, you are no longer facing one giant unknown. You are facing four smaller, much more approachable questions. You can work on each one individually, test it, and move on to the next. This same approach applies when you encounter a bug. Instead of thinking my page is broken, you ask, what exactly is the observed behavior? For example, the button click does nothing. What was the expected behavior? The form should display a confirmation message. Where in the code could this be happening? The JavaScript function attached to the button. What information do I have? Is there an error in the console? Is the function being called at all? Each of these questions narrows down the area of investigation. You have already practiced reading error messages and using the browser console. Now you understand why. These tools are direct applications of problem breakdown. They help you locate the subproblem rather than staying lost in the hole. The habit of isolating variables. One critical aspect of problem breakdown is learning to isolate variables, meaning changing only one thing at a time when debugging or experimenting. If your layout is broken and you change 5 CSS properties at once, you will not know which one fixed or broke the issue. Instead, you modify one property, observe the result, and then proceed. This mirrors the scientific method. You form a hypothesis. I think the issue is the margin on this element. You test it, you change the margin and observe the result, and you draw a conclusion. Yes, removing the margin fixed it, or no, the problem is somewhere else. This discipline is what separates a developer who spends 3 hours randomly trying things from one who identifies a bug in 15 minutes. It requires patience and intentionally, but it becomes second nature with practice. Curiosity as a professional tool. The second pillar of the developer mindset is curiosity, not passive curiosity, but active and structured exploration. Development is a field that evolves constantly. New tools, new frameworks, new best practices appear regularly. No school or training program can teach you everything you will ever need. What they can do, what this course does, is give you the foundations and the methodology to keep learning on your own. Curiosity in development means several things in practice. When something works, you ask yourself why it works, not just that it works. For example, you saw that adding display flex to a container element changes how its children are arranged. A curious developer asks, what exactly does display flex do? What other values can display take, and what do they do? When you read documentation or a tutorial and encounter an unfamiliar term, you note it and look it up. You do not skip over it and hope it will not matter. When you encounter an error message, You read it carefully and search for it. You have already practiced this. A curious developer treats error messages as useful information, not as obstacles. When something unexpected happens, for instance, a style that should apply does not seem to, you investigate. You open the browser developer tools, inspect the element, and understand what is actually happening rather than just patching it blindly. Curiosity is also about exploring beyond the immediate task. If you are building an HTML form and you discover there is a required attribute that prevents the form from being submitted if a field is empty, a curious developer experiments with it. What happens if I add it? What does the browser do automatically? Does it work on all browsers the same way? This kind of exploration builds a much deeper and more durable understanding than simply copying what you are shown. Accepting uncertainty and embracing iteration. One of the biggest mental shifts for beginners coming from other professions is accepting that uncertainty is a normal part of the job. In development, you will regularly find yourself in situations where you do not know the answer, where the documentation is unclear, or where two solutions seem equally valid. The developer mindset means being comfortable with that uncertainty and moving forward anyway. You make a reasonable choice based on what you know, you implement it, you test it, and you adjust. This iterative approach, build, test, observe, adjust, is not a sign of incompetence. It is the actual process that professional developers use every day. For example, when you created your first HTML page and refreshed the browser to see the result, you were already practicing iteration. You did not write the entire page perfectly in one go. You wrote something, checked it, fixed it, and moved forward. At a larger scale, this is the same process used to build entire web applications. Knowing where to look for information. A developer who knows how to search for information efficiently is far more productive than one who relies solely on memory. Knowing where to look is itself a skill. The most commonly used and reliable sources include the official documentation of the technology you are using. For HTML and CSS, the Mozilla Developer Network, commonly referred to as MDN, is the reference. It is precise, well-organized, and free. Search engines, used with specific and targeted queries. Instead of searching "Why is my CSS not working?", you search CSS margin not applying to inline element, a precise description of the actual problem. The browser developer tools themselves, which you have already practiced. They let you inspect and understand what the browser is actually doing with your code in real time. Error messages, which often contain the file name, the line number, and a description of what went wrong. These are starting points for your investigation, not just red warnings to dismiss. Knowing how to use these resources effectively is something you develop over time. At the beginning, every search takes longer. Over time, you recognize patterns, you know which sources to trust, and you find answers faster. Putting it all together. A practical example. Imagine you have built a simple web page and you notice that an image is not displaying. Here is how the developer mindset applies. You do not panic. You break the problem down. Is the image file actually in the right folder? Is the file path in the HTML correct? Is the file name spelled exactly right, including uppercase and lowercase letters? You isolate the variable. You check each possible cause one at a time. You use your tools. You open the browser developer tools. Look at the console for errors. Inspect the image element to see what source path the browser is actually trying to load. You are curious. You notice that the error message says 404 not found for the image. You now know it is a path issue, not a code syntax issue. You search for HTML image path not found to confirm your understanding. You iterate. You correct the path, refresh the browser, and confirm the image now displays. This process, calm, systematic, tool-assisted, curious, is exactly what professional developers do, whether they have 1 year of experience or 10. Conclusion: a mindset you build every day. The developer mindset is not something you acquire in a single lesson. It is built through repeated practice, through every bug you debug, every feature you build, every error message you read carefully instead of dismissing. The two pillars, problem breakdown and active curiosity, reinforce each other. Breaking problems down gives you specific questions to explore. Curiosity gives you the motivation and the habits to explore them well. As you move forward in this course into HTML structure, CSS layout, JavaScript logic, and eventually back-end development with Node.js and databases, you will constantly return to these two habits. They are the meta skills that make all other technical skills more effective. Start practicing them now, from the very first line of code you write.